organize how the companies are built in order to be able to fundamentally take advantage of it. And so what I've been doing is when I got to know all these guys at UF, they've plugged me in with the industrial and systems engineering faculty, and we're actually exploring doing some research about the applicability of industrial and systems engineering to software organizations, okay? So what this talk is fundamentally about is why I think that's an important thing for folks to consider. Does that make sense? So that's kind of my hypothesis. Yes, sir?
You're talking about Agile because Scrum.
You're a certified Scrum guy. Yeah, awesome, excellent. Well, so part of like when I first started getting involved in Agile was probably about 10 or 12 years ago. And I was working with the development team that was trying to do Scrum. Okay, they're using extreme programming or some of the other methodologies around it. And what was happening is that they were really struggling with it. And so what we started looking at was what was going on in the organization that was causing them to have problems with the process. Because Scrum is, we'll get into Scrum and everything in a little bit. So let me kind of start my story from the beginning, okay? This is really fascinating that this thing doesn't want to advance for me, so maybe I wouldn't think I'm too far away from it. So what I'm going to do is I'm going to start off with a little bit of like a brief history of Agile. I'm going to talk about where it came from, just to give you kind of a philosophical underpinning. And then I'm going to talk about why it works and why it's important. And then we're going to try to like wrap it up with like why I think industrial engineers should care. And if my little thing does not start clicking, I'm going to get really upset with it. Okay, cool. So software, if you think about it, has really only been around as a thing for about 30, 40, maybe 50 years, right? It's a relatively new discipline in the scheme of things. And so what basically happened is that all of this is, from 1943, through 1990, there's all this precursor iterative and incremental delivery that kind of like got popularized with this thing called Scrum. And so the first thing that I want you guys to know is that Agile is not like one thing. What Agile is, it's a family of lightweight methodologies for building software. Does that make sense? Okay? So that's like the first most basic concept. So there's lots of things that could be considered Agile. The things that you might hear if you're working with software people are things like Scrum, extreme programming, feature-driven development. Lean is up there, right? There is lean software development, right? That's kind of where it gets the closest to what you're thinking about, maybe in terms of like industrial and systems engineering stuff. But what happened is 17 people got together in a little town called Snowbird, Utah, and they were like consultants and people that were exploring these kinds of ideas in industry. And what they did is they came up with this thing called the Agile Manifesto, okay? And what they were fundamentally trying to do was software to that point, when these methodologies started to emerge, was largely, and still is in a lot of ways, built almost like you might build a house. So if you think about how you build a house, you do like a big blueprint, right? Ask the people what they want, you do a big price estimate on it, then you would go build the house, and then they do a walkthrough and say, do you like the house? And we'd sign off on it, maybe we'd fix some things, and then you would pay the money and get the house, right? So software has kind of been built that way for a long time. And what was going on is that as software becomes more and more embedded in what we're doing as business people, and even in manufacturing and lots of things you guys are probably more native to, the need to get software delivered faster is really important. The need to be able to get things into market so we can start making money with them earlier is really important. So all these methodologies are beginning to emerge. These 17 thinkers and industry people got together in Snowbird, Utah, and they created this thing called the Agile Manifesto, okay? And basically what they were doing is they said, okay, what do all these little lightweight communication like methodologies have in common? And what they said is they said individuals and interactions over processes and tools. So what they were basically saying is that people collaborating with each other is better than basically doing handoffs from station to station, okay? Working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. Okay, let me ask you guys a question. Is any of this like kind of relevant at all? Does it make sense, or do I need to like even take a step further back? Because I can go off and we can do anything we need. I want to make this really valuable to you guys. Okay?
No, it's okay.
You're okay? Well, you've been to Scrum training though. You know, right? All these guys I don't know that they know. So here, I'm going to re-anchor this. I'm going to try to say this one time. Let's have some conversation around it, okay? So if you think about software as like an assembly line, okay, with different processing steps, okay? So software is like analysis, design, build, test, deploy. That's typically the value stream associated with Agile, or with software development. And so what was happening is that think about like that value stream being delivered in large batches, okay, with big handoffs in between. Make sense so far? Okay? So large batches, lots of work in process all at one time, and gigantic handoffs that are very prone to error. Okay? So what Agile just very intuitively came up with is this idea that we're going to wrap the entire value stream in a team. Okay? And we're going to put all the processing steps associated with Agile into a single development unit, and we're going to let them work together and collaborate to build software. Does that make sense? And so what we're fundamentally going to do is we're going to start to focus on reducing batch size, limiting work in process, and encouraging flow. Okay? That's Agile at its like most fundamental level, I think, from an industrial and systems engineering perspective. Okay? Make sense? You guys are all like tired. Nobody's talking to me. Does that sound consistent with the things that I've told you before?
Yeah, right on.
Jeff? Okay, cool. So what these guys were doing is they were basically saying large batch sizes are bad, too much work in process is bad, having bottlenecks in the system is bad. So what we want to try to do is we want to try to minimize handoffs, and we want to try to increase collaboration. So what they basically said, that was when the first thing came in. It's like, what we want to do is we want to empower people, we want to respect people, we want to get them talking to each other, we want to get them to collaborate with each other, and we want to do that over like having big system handoffs, okay? So working software over comprehensive documentation. One of the things software people are really, really bad at is this idea of getting things into market fast. What software people often like to do is to do big documents describing what they're going to do, and then like taking a long time to actually build the software. So what we're trying to do is we're trying to say, okay, we want to really lighten up the documentation, and we want to focus on getting things into market faster. We want to use working tested software as the measure of progress, okay? We want to collaborate with our customers to build what they want instead of trying to do it through like a big RFP process or a big contract negotiation up front. And we want to create plans that are resilient to change, okay? Trying to figure out like what's a good anchor point to get you guys to engage with me a little bit. Does that make sense? You guys with me? Okay, cool. So I'm going to skip this next slide. People that are doing Agile software development are typically trying to achieve the same kinds of goals that I believe that industrial and systems engineers are trying to achieve in manufacturing organizations. Okay? So we're going for predictability. We're trying to get things in market fast. We're trying to deliver higher quality. We're trying to reduce costs to eliminate waste. We're trying to make sure that we're building the right product that a customer will buy. And we're trying to create ecosystems in our companies that drive innovation. Do those things resonate with you guys? Okay, cool, awesome, good deal. Okay, but here's where I think software is a little different, is that software is fundamentally knowledge work. Whereas like on an assembly line, it's like we're not doing custom work as we go. What we're doing is we're basically producing generally like a repeatable progress, like a widget or something, like something that can be designed and built and then mass manufactured, right? And we're testing for quality and adherence to spec and all those kinds of things. But with software, what makes software a little bit more complicated is that software is really about solving problems. It's about figuring out how to do something. And so if you think about the thing that is going through the assembly line in software, it's an idea. Make sense? It's like a behavior in the system that is getting progressively processed through like a software manufacturing assembly line into something that will show up on your iPhone that you could actually use. Right? It's a feature in the software that you might use. Does that make sense? Okay? So it's the processing of the idea that goes through the assembly line. And so the fact that software is knowledge work makes it, I think, unique from manufacturing. It's almost like the difference between designing a car and building it once it becomes, once it's actually been designed. Okay? So what we're doing is that the concepts between manufacturing and assembly lines and things like that, they're very similar to what we're doing in software, but it's the idea that's running through the system. Okay? There you go. Okay. So this next set of slides is the reason why I think industrial and systems engineering needs to be applied systematically to software organizations. So I'm going to tell you guys a little bit about how software organizations grow and why they fail and why they get slow and why they need you guys. Okay? The reason why is because most software, when it gets started, tends to happen. You guys have heard there's almost like a myth in software of people building technology in garages, okay? Because typically when a company starts up or a division starts up or even an idea within a big company starts up, what it typically does is there's typically a small cross-functional group of people that are responsible for working together as a team to build the product, okay? And then what starts to happen is during that time, everybody owns getting that product into market. Everybody's collaborating, everybody's working together. Everybody's kind of doing everything almost irregardless of specialty. Because a lot of times when organizations are small, you have to do that kind of out of necessity. So what's happened in most software organizations is that as they get bigger, what starts to happen is that they start organizing for activity instead of organizing for outcome. And what does that look like? So in the previous slide, you might have the project manager, the analyst, the designer, the people that are writing the code, and testing all in the same room. And that will often work up until you get to about 10, 15, 20, 25 people. And then typically what will happen is that you'll need more developers because you want to build faster. So what happens, Jeff, when I need to hire more developers?
You take the best developer and say, you're in charge of the developers?
You're the boss.
Go hire more.
So what happens when you need more project management? It's the same answer.
Basically, yeah. Sure.
Okay. So you hire a bunch of project managers and they all work for the project manager. You hire a bunch of testers, right? Because we want to make sure there's really good quality, right? So we hire a bunch of testers and they all work for the test manager. And then when you get into the thousands of people, a lot of times you'll have the vice president of product development that has all the Java developers working for him. And then you'll have the president of quality who has all the quality testers working for them. And what you end up with is a set of functional silos, okay? And here's the interesting design flaw in most software organizations, is when you have a silo of analysts, they become responsible for analysis. When you have a silo of developers, they become responsible for development. When you have a silo of quality testers, they become responsible for quality testing, and on and on and on and on. Okay, test, see if you guys are paying attention to me. When they were the 6 or 7 or 8 people in the garage, who was responsible for giving product to the customer? All of them. These guys have heard me talk a lot, so they're cheating over here. They've heard all my answers before. This is like my fan club over here, so I appreciate them coming. So, everybody's responsible for it. So who's responsible for delivery of product to the customer when everybody's organized into a functional silo? Sales, maybe. That's dangerous, right? But generally what starts to happen is project management is responsible, right? So large software organizations, the way that they're built nowadays is that the requirements come in, project manager facilitates getting them decomposed, turned into a big written document. And then they get handed off to the designers and the architects. And the designers and the architects are responsible for doing their part. And then it gets handed off to the people that are building the software, and then they do their part. And then it gets handed off to the testers, and they do their part. And what happens is by the time it gets to the testers, the developers have moved on to something else. The requirements analysts have moved on to something else. Okay? And so what happens if there's a defect in production of software? What it does is it creates a negative feedback loop in the organization. And what starts to happen is that when you have hundreds of projects running through the organization, all on different schedules requiring different levels of resources, in the best case scenario, that's incredibly difficult because software is about the processing of ideas, right? So sometimes the idea isn't quite perfect, right? We don't know exactly what to build. We don't know exactly how long it's going to take. So in software, there's a tremendous amount of variation in the processing between step to step. And then if we get something wrong, it creates negative feedback loops in the organization that further destabilize delivery. Okay? And so what we're basically doing with Agile, okay, and this is a core concept, and I want to anchor it into what you guys do, which is why I'm kind of going to great lengths to do this. What we want to do in Agile is we want to organize around outcome rather than organizing around activity. So we kind of want to go back to where we started in the garage, and we want to start to think about networks of teams within large enterprises that are organized around what the company actually produces. Okay, so for me, what that starts to look like is very much like what we had in the initial, like 8 people in a garage kind of a thing. And so the metaphor that I like to use, actually I did this, I did a variant of this talk up in Detroit, and I had a lot of people from Ford Motor Company in the room. And what's interesting is large manufacturing companies, they very much are great at applying these ideas in manufacturing, but even the big ones that really understand industrial and systems engineering at scale for manufacturing don't know how to apply these ideas into software. And so I had a bunch of Ford Motor Company software people in the room. And the analogy that I would use is, if you think about it, is that when you're building a car at scale, like it's not like a small team of people that are hand building a car, unless you're working for like some exotic car company in Italy or something like that. I think it happens that way there. But what you basically have is you have a supplier system, right? And excuse me. And so you have component builders, and those components get rolled up into subsystems, and those subsystems get rolled up into systems, and then the systems get integrated on the assembly line into completed cars. And it all starts to kind of happen in a just-in-time way. Okay, I think that's a big part of what you guys do, isn't it? Right? At least what you guys learn about, right? And so what we're fundamentally doing, what we have to figure out how to solve, and I'm going to go in and I'm going to talk to you guys a little bit about what the process of doing Agile is, so you guys have exposure to it. But the big problem for industrial and systems engineers, as I think as a discipline, and this is kind of fundamentally my hypothesis, is that We have to think about how to organize software companies effectively so that they can take advantage of these processes. And so if you look at like a large company like Amazon.com or Facebook or like a lot of the big successful e-commerce groups, what they do is they basically organize their teams around stuff that the system does. So this is a gross oversimplification, but if you think about Amazon.com, think about the things that you do with it, right? You search for a product, you check out, you do a return, right? You might buy a Kindle book. You know, there's different stores within Amazon.com. What you find is that there's components in large software systems that are common, and then there's stuff that gets consumed. Any Spotify users in the room? Spotify is a big, famous kind of Agile implementation. If you look at all the little bits that are in Spotify, each of those little bits is handled by a small cross-functional team. Okay? They have the ability to operate autonomously within their piece of the software. They get pulled into the big wrapper. All the pieces within Amazon are all done by small cross-functional teams, and they're in kind of a big portal kind of wrapper. If you think about it, most large successful software companies are kind of built that way. Okay? Most modern large software companies are built that way. The challenge is that a lot of what I would call legacy companies are not built that way. They're built more like the old model that I was talking about. Okay? So the thing that, so there's a couple things, right? So when you guys, if you ever get out in industry and you learn about Agile or you learn about lean software development, there's a set of practices and processes, things you learned about in your Scrum training that enable small teams. But what's happening in industry right now in software is that those practices are being applied. I don't know why the range on my little clicker is so bad today. They're being applied in these kinds of organizations. And they don't work in these kinds of organizations. And so in a lot of ways, Agile's creating chaos in some of these organizations. Okay? So what my company does, and this is why I think this is so important, obviously, is that you have to re-engineer the software enterprise to start to be able to take advantage of these new modern ways of building software. Okay? And I'm going to explain a little bit about what I mean by that. Okay? Any questions? Pause for a second, see if you guys have anything you want to talk about. No? Yeah, it's kind of interesting. These are like really interesting concepts if you don't have any foundational experience like building software or stuff like that. But is it at least kind of like making conceptual sense the way I'm telling the story? Okay, cool. Because I'd hate for you guys to spend an hour with me and go, God, that guy would talk about Agile was awful. So let's skip over that. So let's talk about this. So one of the things I talk about is that if you were an industrial and systems engineer and you were going to walk into an organization and you were going to try to help it become more agile, okay? The three fundamental basic things that you would want to look for is you would want to look for, can you form a delivery unit like that I was talking about? So a group of people that have authority and ownership over something that the company builds. Okay? So that's kind of like one of the first preconditions for Agile. Okay? The next precondition, and I'm not going to go into some of these details because I think it'll be a little overwhelming, right? So that team of people needs to have a very clear backlog of things that they're supposed to build. And what they have to be able to do is to produce something of measurable value on regular increments. Have you guys ever heard of something in your studies, statistical process control? No? Yeah, okay, cool. So I'm kind of a novice. I know enough about industrial engineering to probably be dangerous, so if you guys catch me saying something's a little bit off, make sure you pull me back to center, okay? But my understanding of statistical process control is if you're producing things and there's lots of variation in the tolerances, right? And maybe even the variation exceeds the tolerances, what we want to do is we want to stop right? We want to fix it before we get too far, right? We don't want to let defects kind of accumulate in the queue, okay? So what we're trying to do with Agile is that backlog is in effect a list of ideas. The team is like a work cell that is responsible in its entirety for processing the ideas. And then on regular intervals, we're going to measure how much the ideas actually conform to the tolerances that are specified in the backlog. Okay? Now, in the small, right, single team, that's like really, really straightforward. Okay? As long as I have a team, as long as they've got a really clear, concise set of ideas, and that they're able to produce something of measurable value at the end of that period of performance, then what can start to happen is we can start to think about how it is that we want to, provide feedback. Because if the things are not satisfying the customer, then we want to fix them before we go on to the next thing. Okay, so in Agile, we have this notion of backlog size, and we have a notion of velocity. And backlog size is the estimate on what we think it's going to take to actually build the ideas that are in the queue. And then velocity is the rate at which we can complete the ideas in the queue. It's kind of like our throughput metric. And then what we're going to start to do is we can use the size of the backlog and the rate of completion to start to derive how long it's going to take to get through that backlog. Make sense? Yeah.
Maybe could you give an example of like what the backlog is and how a team would work on it?
Yeah, so like give me an idea, right? So you and I speak the same language on this. Like give me an idea of like what you're thinking
Just
about.
kind of to illustrate maybe some of the backlog terms and what you mean by processing ideas.
Mm-hmm.
So when they're actually building software, what would be in the backlog, and in like just an example of them producing value on an increment of time. What does that look like?
So does anybody have an app that they have to log into on their phone? Yeah, okay, cool, right? So if I were going to build your login app on in whatever it is that you're logging into, if you think about all of the behaviors associated with login very explicitly, what might be the first thing that we want to do? Maybe we want to be able to put in a correct user ID and a correct password and be granted access into the system. That's an idea, right? The next idea might be, what if I put in a wrong password, right? I might want to give you a message saying that you logged in incorrectly. Okay, you have to enter in a new password, okay? I might want to have password strength rules. Anybody have a password that is like has to be all kinds of crazy characters or something like that? That's a feature in the software. Anybody ever work in an application that they log in 3 times wrong and they have to do a password reset? That's something that's in the backlog. Okay? So what you start to think about is you start to think about how to express the requirements of your software in terms of little bits of functionality that you can build, put in front of a customer, and be able to get feedback on. Okay? Now you guys, it's really fascinating, right, as we go through generational change on this kind of thing. How many people have an app on their phone that you probably get a new version of it every 2 or 3 weeks? Does that happen a lot? Right? That is the result of an Agile team building feature functionality. Right? So every time you get that download, they fix some bugs, they add some new features. Facebook's doing it all over the place. Does anybody still use Facebook, or are you guys just all Snapchat now? Okay, I think Facebook's just becoming for old people at this point, but I think sometimes kids come back after they leave college and they don't mind actually having social media with their parents, you know? I think Snapchat's where they go to hide for a few years, and then Facebook's like when they want to like become public again, something like that. Well, like, so what are some of the changes that Facebook is making lately? You notice how like you have like those colored, like they almost look like memes a little bit, where you can do like colored text instead of just like a line of text, right? Something I noticed that came down the last Facebook thing is like when I click on a post, like instead of just showing me likes, this little crazy little cloud of likes floats across the screen. You guys ever seen that one? Yeah, it's like keeps throwing me off every time. I'm like, it's kind of, but it's like those are like little features, right? So Facebook's adding like little features all the time, okay? So what you might think is like those people that are responsible for the like portion of the app, right? They probably have a list of ideas that they want to build. And then they have a team that's responsible for building that part of the app, and that team builds those things, and every couple of weeks, they push it out to the App Store, and they do that, right? That's Agile, right? I mean, that's just Agile in a nutshell, okay? The challenge is, and this is where it's like I always catch myself, because one of the, I didn't say this in my introduction, but one of the neat things that I've gotten to do is that my company's actually been pretty successful. We're about 60 people, and University of Florida has this thing called the Gator 100, which is like the list of like the fastest growing Gator-run companies in the world, right? And so 2 years ago, we hit number 3 on that list. We were growing super fast. And I took on a volunteer role with the university called Entrepreneur in Residence. And so that's how I got to know all these guys. And so I come down every month or so during fall and spring, and I do talks on Agile and different things that I'm interested in leadership and stuff like that. And sometimes I realize that I'm almost becoming a little bit of a cynic, okay? And I realize that you guys are all like excited, and you're getting ready to get out and start your careers, and you probably, like, all these companies are awesome, and they're giving you jobs, and they're doing all this kind of stuff. But what you're gonna realize is when you get into companies, is that a lot of these companies are kind of jacked up. Right? A lot of the companies that are out here talking, right? They're awesome companies, right? They're doing great. But when you get in the middle of them, right, there's a lot of challenges, because as companies get big, they start doing all the things that I was just talking about, and they stop organizing around value, and they start organizing around activity. And who is it? Ellie Weinbell, is that who you say her last name?
Procter & Gamble, yeah.
Yeah, so Ellie's working for Procter & Gamble, and she was an intern, and we were talking over lunch one day. And like sometimes when you get out of school, right, you get like assigned a small problem, right, to go optimize something, okay? Like maybe if you were industrial engineering on a software thing, you say, okay, well, I've got a single team that I'm gonna go deal with, right? And you're gonna help that team get better, or you're gonna help fix this process. The challenge is that some of these companies you guys are gonna go work for have gigantic process problems, right? They have organizational problems. And so it'd be like if you went into Facebook, and instead of having 8 people working on trying to figure out how to implement the like functionality, you had 1,000 people that were all trying to do a million things across the whole thing all at one time, right? And so that's where Agile gets tough. And so what I just kind of want to give you guys a heads up on is that when, what I want to kind of not leave you with, we're not done here, but where I want you guys to anchor is that if you get exposed to Agile through your coursework, or you get exposed to Agile when you get out and get jobs, Agile is designed to operate in a context. It's designed to operate with a small team working on a clear list of ideas that are able to produce something that they can put in market every couple of weeks, okay? So again, just kind of taking it up a level, I think the opportunity for industrial and systems engineering on the whole is to figure out like how do we reorganize the plant floor? How do we do this across the entire organization? Right? Any thoughts? Questions? How are we doing on time? Not bad. 40 minutes. Okay, cool. It's funny how fast time, you think like you guys get up and do talks, and it's like, you think that like time stands still sometimes and you have to figure out how to talk. Like I'm the exact opposite. Like I look up and like half my time's gone all the time, right? So is this making sense? Is this relevant? You guys haven't left yet, so I'm assuming that we're doing something okay here. Okay, so let's talk about the Scrum process itself. Like I said, I didn't really intend to go through a ton of slides, but I'm glad I brought them now. So let's talk about the basic processes of Scrum, okay? Basic processes, all things Agile, right, really kind of come down to this basic process flow. So what Agile is about, it's about delivering in loops, right? Delivering in short cycles. And so the way that I was just describing, so think about this, right? So everything is about having a team with a clear set of ideas that can produce something of value. That is the fundamental anchor of being able to do Agile. So typically, there is a role in Agile that is called the product owner, somebody who is responsible for identifying the requirements. And they create this artifact called a product backlog. That was the list of ideas that I was talking about, like when we were trying to explain like the feature sets within, Facebook or Amazon or something. So what happens is that the product owner is responsible for that entire backlog set. Then the product owner meets with the team every 2 to 4 weeks, and the team gets to decide how much of this backlog they're going to pull into the next performance period. Scrum calls that a sprint, or it might also be called an iteration if you're using extreme programming or some of the other methodologies. Okay? So we have this thing called a sprint backlog. And what the sprint backlog is, it's that subset of the product backlog that the team is committed to deliver in the next 2 to 4 weeks. Okay? That ceremony is called a sprint planning meeting. Okay? The team then is responsible during that 2 to 4 week period for delivering the things that are in their sprint backlog in kind of a continuous flow manner. So even within the sprint, we kind of don't like large batch sizes. We want to focus on getting things through the system, right? Getting things done before we get new things started. Okay? So what the team does is every 24 hours, they have this thing called a daily stand-up meeting or a daily scrum, where they kind of check in with each other and they help each other and they assess and they say, okay, how are we progressing against getting our sprint commitments done? And then at the end of it, the idea is that they have turned the things that are in their sprint backlog into something that could be deployed into production. So the people that were responsible for that little like app, right, the little like bubbles, right? So there was probably a list of 100 things, and at some point in time they decided those little like bubbles were the most important thing on their backlog. They get together with their product owner describes it, they figure out how they want to build it, and then sometime during that 2 to 4 week period, they build that feature, and then they show it to the product owner, and the product owner says, yep, that's awesome, that's exactly what I wanted. And then they put it in the app, and they actually get it out in the app store, and then next time you download your app, you got it. Make sense? With me? Any questions? Yeah, please.
So I feel like a lot of times when you have an issue, it might sound like you get it done in like a week or so, but then you go to do it, and you realize it's going to take you like months.
Takes time, yeah.
So then, like, what would you do?
Yeah, well, so in that particular case, like the really straight, easy answer to the question is you just wouldn't deploy it in that sprint, and it would carry over and maybe get delivered into the next sprint.
What
Go
if
ahead.
though it was something that you realized was like important to, like it was an important thing?
Like really had to be done?
Yeah.
Yeah. So when we go in and teach this to people, there's a couple of things. I'm going to answer your question on a couple levels, okay? So the first thing is that we try to get the organization really good at breaking things in the product backlog up into little small pieces, okay? And then when they pull it into the sprint backlog, the team does kind of the analysis and design and tries to figure out if they think that it can actually be pulled into the sprint. Now I'll tell you one thing that's kind of interesting, and there's a lot of nuance in what I'm getting ready to say, but Agile's a really hard thing to do if you have really firm like scope deadlines, okay? Because there's this thing in project management called the triple constraints. Okay, now this is going to be kind of weird, a little esoteric. I'm glad you came back. I thought maybe you just said, I'm out of here, you know? There's this thing called the triple constraints where it talks about on any project, you have time, you have cost, and you have scope, right? Does that make sense? And the thing with project management is that you can typically pick two, but then you've got to derive the third. So like, let's say, for example, if I came to you and said, in that product backlog, you have to build these 10 things, and you only have this team of people to do it, Okay, so that's kind of your cost, right? The people that are going to do it. The third variable, time, would have to be derived from scope and cost, okay, to try to figure out how long it's going to take. If I had scope and time, okay, like I'm getting ready to go to a trade show and I have to have all 10 of these features and they have to be done by September, well then what you might have to do is you might have to throw a lot of people at it, which would drive your cost, to be able to get done on time. What Agile typically does is that it fixes time and cost, the size of the team and the amount of time the team has, and then lets the team figure out how much can be built within that period of performance. Okay? And so one of the things that's really fascinating that's going on in software right now is that you've got different kinds of projects with different needs. Okay? So there's some projects that are really, really well understood, like where I really know what's in that backlog. I can estimate what's in the backlog. The team knows how to decompose it. They know how to do the work. They can deliver, and they can deliver really reliably and predictably. Okay? On the other end of that spectrum, I worked with this one company, and what they were building was mobile testing software for iPhones. And the approach that they had taken in market, which was their differentiator, which they ended up pivoting off of, was that they were like doing screenshots of like the iPhone and using object recognition. They were creating algorithms to figure out if like the button was to the left or to the right, if the button was pressed or if they're not. And I would sit there and I would talk to the engineers and I would say, kind of to your point, how long is it going to take to write the algorithm to identify if that button's on or not? They'd say, I don't know. It could take me 2 days or it could take me 3 months. Okay? Because they're inventing math, object recognition technology, right? They have no idea, right? It doesn't exist today. Had another client that was very similar. They were building quantitative algorithms to help people manage stock market portfolios. Okay? They're like inventing math to try to figure out how to make predictions about the stock market. And you ask yourself, you go, how long is that going to take? I don't know. Right? We don't know, right? And so that's the kind of the interesting thing with software, is that certain things we're doing really skew themselves towards R&D. It's like we don't know what it's going to look like. Okay? Then on the other side, there's things that are pretty knowable. So if we have a system that is knowable, okay, then I can get a really clear backlog, I get a dedicated team, I get the team to own it, and I can start stabilizing my throughput and start delivering against that backlog in a really predictable way. On the other end of the spectrum, I have things that are more R&D, and I can still use Agile to do that, but those ideas become like experiments or hypotheses. Okay? I think I can deliver that algorithm in 2 weeks. At the end of the 2 weeks, I'm going to measure if I did it or not. Then if I did do it, awesome. If I didn't do it, then I have to decide if I want to give it another 2 weeks, and then another 2 weeks. And the root of your question, I'm not giving you like a totally long answer to like a pretty short question, but the root of what the challenge with that is that you have a lot of people in software, because software is soft, right? It doesn't have the hard costs of manufacturing in the same way. It's not as tangible as manufacturing. They have things like where they have to be in market by a certain time with a certain set of functionalities, but the engineers can't invent it fast enough, so they fail. I'll tell you an interesting story. So we're in Pittsburgh. Is anybody from the South? Yeah? Anybody eat at Chick-fil-A? Okay, yeah, cool. Okay, cool. Because Chick-fil-A's are starting to wind their way. So Chick-fil-A is not a huge client of ours, but we spend a little bit of time with them. You know how long it took them to develop that spicy chicken sandwich that they have? Anyone want to guess? No brave souls want to try to guess? What would seem like an incredibly long time to invent the chicken sandwich?
3 years.
5 years, 3 years. 10 years it took them to invent that chicken sandwich, right? One thing they're trying to do right now is they're trying to create a smaller fryer that takes up less space in the kitchen for their chicken nuggets. But you know what? When they shrink the size of the fryer, for some reason it changes the taste of the chicken nuggets. How long does it take to develop a new chicken fryer that doesn't change the taste of the chicken nuggets? I don't know, right? I don't think anybody knows, right? So there's certain things that don't lend themselves to very defined outcomes. So what's really fascinating with Agile is you can use the same kind of processes for very deterministic systems, okay? But you can also use it to manage variation in very experimental systems, right? It's fascinating because, you know, again, if I know exactly what to build and how to build it, and I can put it in my backlog and estimate it, then click, 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 right? If there's a ton of variation in the experimentation, I can use the same process to kind of go, okay, we've been working on chicken sandwich for a year. Do you want to give it another year? You want to give it another year? Another year? 6 more years, right? You know, that kind of a thing, right? So that's fascinating, right? So it's interesting, right? So again, right, what I'm kind of priming you guys for is that the process of Agile is a really well-defined thing. If anybody's really interested and wants to go deeper, if you go to scrum.org, you can download, I think that's also up on the scrumalliance.com, maybe it's scrumalliance.org, but you can download a 20-page free description of Agile, right? Tells you exactly how to do it, okay? But what it doesn't tell you how to do is the 2 things we just talked about. How to create the conditions in the organization for it to be successful, or how to situationally apply it to achieve different kinds of outcomes within the enterprise, okay? So again, another process improvement application for this. It's not good enough just to know how to run a daily stand-up meeting or how to build backlog or how to do whatever. You got to figure out how to create the right kinds of conditions for that process to work, and you have to understand how to apply them so that the business gets the outcomes associated with that they need. It's kind of fascinating, okay? And so I'm going to go kind of advanced on you guys for just a second. So when we are doing large-scale transformations in banks and other large organizations, oftentimes what we're trying to do is we're trying to figure out how to get Scrum implemented across the organization. So what that means is, like what I was just saying, is we have to help them figure out what they're going to organize teams around, like what the work cells on the assembly line are, okay? Where they're going to get their inputs and how we're going to measure their outputs. And so in its simplest way, that's actually a really tough challenge, just to figure out how to get them to organize. But more often than not, we are having to restructure their organizations. Sometimes we lay off hundreds of people with them. Sometimes they're missing people that we have to go find because their organizations are out of balance, okay? So, but that's the bottom layer. Then, what starts to happen though, that's all happening in the team, is the stuff at the bottom layer. What starts to happen is that it takes 10, 15, 20, 100 teams to build something of integrated value for the organization, okay? So imagine the supply chain associated with all of the components, subcomponents, sub-harnesses, harnesses, right? All the things that get wound up and built into a car that eventually go through an assembly line process, right? The processes that ride just above team level execution are very similar. That middle tier, we use like a Kanban-based queuing system. That's a value stream, right? That's basically like a process flow. And so what we're basically doing is we're saying when work is ready, right? When it's ready to enter the queue, we're going to take it and we're going to break down the features. We're going to turn them into small little requirements Agilists like to call user stories. The stories will get reviewed, they'll get built, they'll get integrated, and then when that feature is complete, right, then we have something that's ready across all 100 of those teams to go to market. At the top level, you can see it's all the way from idea, all the way from concept, all the way to cash. I don't know if you guys use that expression. That's actually something I learned out of some of the lean software development methodologies. The entire value stream goes all the way from concept to cash. So the kinds of systems that we're building in large organizations are basically taking high-level ideas, running them through a process of market research, feasibility, targeting a release, through detailed planning, getting them ready to build, developed and tested, and then ultimately done. As the big ideas run through that top value stream, they drop down into the lower value streams. But you can model it all in one line if you wanted to, but I like to model it in multiple tiers, right? So when it gets to detailed planning, it drops down and goes into feature breakdown, story mapping, review, goes up to ready to build. When it's developed and test, it's down at developed and test at the team level, gets integrated, feature complete, and then ready to go to market. Okay? So you can start to see, I know it's probably, these are like big, gigantic concepts and all kind of brand new, but if you think about it, so I just wanted to like just drive home the fact that what we're doing in large organizations, I also believe is a value stream problem. It's a limiting work in process problem. It's an identifying the bottleneck problem. It's reducing waste kind of a problem. It's an improving the system kind of problem. So the metaphor that I was kind of working on with these guys over the last year was it's like the difference between a local optimization, like fixing a little thing that's broken in an enterprise, and having the opportunity to re-orchestrate, like or re-engineer the entire like assembly plant. Right? Have you ever seen anybody do that? Have you ever seen anybody gut an assembly plant and totally rebuild it? I was actually involved in two. My first gig out of school, maybe this is, I never really actually thought about this, but my first gig out of school was with EDS, who was actually owned by GM at the time, and my first job was at the Buick City Assembly Plant up in Flint, Michigan. It's actually closed now, but I actually watched them totally rebuild that plant to do like the Buick something or other at that time. And this is kind of like what we're doing, right? It's kind of like re-engineering the software assembly line. What do you think? Anything else that I should try to close on? We're a little bit early, but you guys aren't asking me any questions. So I think I might have just thrown as many big ideas at you guys as I can possibly throw at you. What do you think? What do you think, Sarah? No? Okay.
Do you have any more slides?
Well, I mean, I don't know. I don't know if there's any more slides in here. It just goes down into great